Hello, Calc class. This is the start of the notes for section 4.3. So far in chapter 4, or what we're talking about in chapter 4, is just different ways to find the derivative of different types of functions. So we started with the power rule, went to the product rule, went to the quotient rule. Now we're talking about a thing called the chain rule. And what the chain rule is, like it says, it's used to find the derivative of a composite function. That's where you have one function that you plug into a separate function. And so looking at this example right here, 3x minus 4 is a function, but that's being raised to the 7th power. So it's a function inside of another function. So what I want to start with is just some simple review of composite functions. All right, so looking at this example, I want to be able to write what f of g of x is when I have these two equations. So this f of g of x, you start with the inner function. It's this inner function g of x that's getting plugged into function f. So in function f, we have the first term is x squared. We're going to plug in this 2x minus 8 into that function f. So it's going to become 2x minus 8. Okay, that first term was being squared in function f, plus 3 times x. We're going to be plugging function g into there. So it's 2x minus 8. So this would be our function f of g of x. And we can simplify it, do some FOIL, do some distributive property, combine like terms, but this is the idea of a composite function. You're plugging the inner function g into function f. And if we wanted to go the other way around, we could do g of f of x. So that means we're plugging function f into function g. So this function goes, if that's function f, that goes into function g wherever the variable is. So that's going to be 2 times function f, x squared plus 3x, and then subtract 8. And again, we could do some distributive property, combine any like terms if there was any, and simplify from there. Okay? So that's writing the composite function. A key part of the chain rule is identifying what your parts are. Is it the f of g, or is it the f function? Is it the g function? That comes into play a little bit. So what I want to do with these last two examples is we have these functions, and I want to write it as a composite of two functions. All right, so basically I want to say y equals f of g of x, but I want to identify what is f, what is g. So looking at function y, what we really have is a function, something, raised to the 8th power. But instead of x, what we have is this 9x plus 4. So there they are. Those are the two functions. F of x is this x to the 8th. G of x is that 9x plus 4 that was being plugged into function f. And so what we have is y equals f of g of x, where these are our two individual functions. Okay? Same thing's happening with this second example. What we have is the square root of x cubed minus 6. And so it's this parenthesis that we're plugging into a square root function. So let's say f of x is the square root of x. In this square root, we're plugging in this thing. All right, and so what we have is our equation y is function f, the square root, where we have plugged in that function g of x, which is the x cubed minus 6. All right, so we're just identifying our functions f and g when it's a composite. That is all for the start of this. We'll talk about what the actual chain rule is to find the derivative of these types of functions in the next one. Bye.